Hello students. So in the previous class we have looked on some examples of chemical change. Okay, so today we are going to see what are chemical change, and we will be also looking at the definition, and then we will try to understand the definition by some examples. Okay, so first is what is a chemical change. Okay, so this should be a permanent change in which new substances are formed with the evolution or absorption of some kind of energy. Okay, so that means in a physical sense it is a permanent change. That means it cannot be reversed. That is, the original substance, once it changes, we cannot get back the original substance once again. Okay, so once it changes means it is completely changed. You cannot get back the original substance again. Due to this, we will get a new substance whenever a change occurs. Okay, so the original substance will completely get changed into a completely new substance. Again, we will see that sometimes what it means, either heat is released or light is released, or sometimes you will see we have to give heat or we have to give light for the change to occur. That means either heat or light will be given out of the change, means due to the change we will get heat or light, or sometimes we have to give heat or light so that the change takes place. Okay, so to understand this we will look at different examples. Okay, so the first example we are looking at is of burning of magnesium ribbon. Okay, so burning of magnesium ribbon. So in your book this example was given, and I have given a brief discussion about it in my earlier class also. So now what is magnesium ribbon? It is confusing. Okay, so you can look over here. So this is what magnesium ribbon look like. It is nothing but it is simple strips. Okay, strips of magnesium. Okay, magnesium is a metal and it is present as a strip. Okay, this is known as magnesium ribbon. Okay. So we will be looking at burning of magnesium ribbon. Okay, so when magnesium ribbon is burnt, what we see? So whenever we bring it near the fire, or we will put it when we will bring it in contact of the fire, and we will see that the magnesium ribbon will start to burn. Okay, and it will give a light from it. Okay, white light will be coming out when magnesium ribbon will burn. Okay, and what will happen? We will also get some powder like substances. Okay, white powder like substances which will slowly fall below. Okay, and during burning of magnesium ribbon we have to collect those white substance which is falling. Okay, so one thing you have to keep in mind, when magnesium ribbon burns it gives light. Okay, and it gives a white powder like substance which is collected in a glass plate or dish. Okay, so what is that white powder like substance? That white powder like substance is magnesium oxide. Here it is written as MgO. Yes, so this MgO, what it is written, this is magnesium oxide. Okay, and when it burns these white substances keep on falling. Okay, and we have to collect them. So that means when magnesium ribbon is burned, in magnesium we have magnesium ribbon we have magnesium metal, and the formula of magnesium metal is Mg. Okay, and when it is burned in air we have oxygen. So during burning of magnesium ribbon, magnesium metal is mixed with oxygen. Okay, and due to this reaction we get magnesium oxide. This is magnesium oxide, and this magnesium oxide is the white powder which falls slowly when you burn the magnesium ribbon. Okay, so in this change, that is, while we burn the magnesium ribbon converts into magnesium oxide as a white powder. Yes, so here what is the change? That is, the change is magnesium ribbon is changing into magnesium oxide through the process of burning. Okay, so in this change we see that a new substance, completely magnesium oxide, which is a new is a substance with magnesium oxide is a substance, and this substance is newly formed. And why it is newly formed? Because we have burnt magnesium ribbon. So burning magnesium ribbon is a change, and due to this change we are getting a new substance which is magnesium oxide. Okay, and what we saw that when we burn magnesium ribbon we get a bright white light. Okay, and we all know that burning any substance also gives heat. If we will burn any substance, suppose we are burning a paper, we are burning a matchbox, we are burning wooden sticks, we will get heat from it. Yes, so burning anything gives us heat, and burning of magnesium ribbon also gives us light, white bright light. Okay, again we see that this change is permanent and irreversible, because once you burn the magnesium ribbon you will get magnesium oxide. Okay, and that magnesium oxide you cannot take back it to magnesium ribbon. Okay, you cannot convert the magnesium oxide to magnesium ribbon. Okay, so that means the change is permanent. Again what you can do, this is how magnesium oxide look like. Okay, so these are the white powder, and this is how magnesium oxide looks like when magnesium ribbon is burnt. Okay, so this magnesium oxide powder, what you can do, you can put them in water. Okay, you can put them here, in this test tube we have water, and what we will get a white colored solution. Okay, this solution is of magnesium hydroxide. Okay, so that is magnesium oxide, this white color powder is put into a water solution so that we get magnesium hydroxide solution. Okay, and this here also, if we look at this properly, so a change is occurring, that is we are changing magnesium oxide to magnesium hydroxide by dissolving it in water. Okay, that means we are putting magnesium oxide in water so that magnesium oxide changes to magnesium hydroxide. So this is also a change. Okay, and in this change also we can see a chemical reaction occurring. So what is the chemical reaction? That is magnesium oxide, that is MgO, is reacting with water to give us magnesium hydroxide. So formula of magnesium hydroxide is MgOH whole 2. Okay, so this is one of the activity to know the chemical change. Okay, so now we will take a very common example of a chemical change. Okay, so that you see this change you see, it's there. Okay, in your day-to-day life, every time you can see this change. What we are looking at simply burning of a matchstick. Okay, so first we are taking a matchstick which is not burned yet. Okay, so then what we will do, we will try to light it. Okay, so once we light it we will get fire. Okay, so that means what happens, the matchstick starts to burn. Okay, so once it starts to burn, then what we will see, it will gradually keep on burning. Okay, so until and unless when the whole matchstick is burnt completely. Okay, so before that you see the matchstick here. Yes, so it is made up of wood. Yes, so when we keep the matchstick burning, so as soon as this wood will be unburnt, up to that time this matchstick will be burning. Yes, so what happens after the whole matchstick burns completely? Okay, so what will be remain? Only the ashes will remain. Yes, ashes in Assamese, ashes are known as sai. Okay, so that means when the matchstick will burn completely, the whole wooden matchstick, it will turn into black ash. Yes, yes, so that means what happens when we burn the matchstick, we get a new substance. And what is the new substance? The new substance is the black ash. Yes, so that means burning the matchstick is also giving us a new substance. Okay, and this change is also irreversible. Why irreversible? Because once the matchstick burned completely, from that burnt matchstick you cannot get back the original matchstick again. Yes, and when burning the matchstick, what we get light, we get heat. Yes, so this is the conclusion we can make from this example also, that is burning the matchstick. In this change also we see that a new substance is forming, then heat and light is evolving. Again this change is also permanent and it is irreversible. Okay, again we will try to look at some other examples. So this is an example which is present in your book, that is action of sulfuric acid on washing soda. Yes, so before going into this example, you all know that sulfuric acid is an example of mineral acid, is it? mineral acid and strong mineral acid. Okay, so here you will be using dilute sulfuric acid. So here you can see DIL dot. Okay, so here you will see DIL dot, that means dilute. Okay, that is, it is mixed with water. Okay, and we are having washing soda. Okay, so what is washing soda? Sodium carbonate. Okay, so in your previous chapter, that is acid, bases and salt, you have already learned that sodium carbonate is an, or sodium carbonate or soda, washing soda is an example of base. Yes, and sulfuric acid is an example of strong mineral acid. So what happens when an acid and base reacts with each other? We get neutralization reaction. So in neutralization reaction, we will get a salt and water. Yes, so similar reaction will take place in this test tube. Okay, in this test tube, what we're doing, we are putting washing soda, and after putting washing soda, we are adding some dilute sulfuric acid to the test tube, and we will see that the neutralization reaction will begin, and we will get a salt, we will get water. But here, since it is carbonate, that means we will also get a gas. Okay, and what is that gas? And gas is carbon dioxide. Okay, so that means from this reaction we will get three products. So what are the three products? One is, so here I have written washing soda. The chemical formula of washing soda is sodium carbonate, that is Na2CO3. Okay, and when we add sodium carbonate with sulfuric acid, we will get a salt, that is sodium sulfate. Okay, so this name of this salt is sodium sulfate. We are getting a salt, we are getting a water. So this is what neutralization reaction is, because an acid, when it reacts with base, we get a neutralization reaction. So in neutralization reaction we get salt and water. But here we are also getting a gas. Okay, and what is that gas? This gas is carbon dioxide. Okay, so this is a chemical reaction. Okay, so that means when we add sodium carbonate and sulfuric acid, a change is occurring, and due to this change, a new substance is forming, that is sodium sulfate. All these substances are new. Yes, sodium sulfate is a new substance. Originally sodium sulfate was not present here. Okay, originally sodium carbonate and sulfuric acid was present. So we are getting a new substance, that is sodium sulfate is a new substance, water is a new substance, carbon dioxide is a new substance. Okay, so that means new substances are formed. Yes, again what we see, that evolution of a gas, which is carbon dioxide. Okay, so a gas is evolved, and that gas is carbon dioxide. Okay, and here also you cannot get back sodium carbonate and sulfuric acid from carbon dioxide, water and sodium sulfate. Okay, so from this you cannot get back the original substances. Okay, so that means the change is permanent and it is irreversible. Okay, so now what we can do, from this reaction you got carbon dioxide. Okay, so that carbon dioxide you can use to turn the lime water milky. So how what happens? So in this slide you see we have a tube here. Yes, so here we have a tube, and what we will do, the carbon dioxide what is coming out of this tube, it will pass through this pipe and will go into this tube. Okay, so carbon dioxide which is coming out from this test tube, it will go through the pipe and it will come into this test tube, and this test tube has lime water. Okay, and what happens when carbon dioxide comes in contact with lime water? So when carbon dioxide will come in contact with lime water, that is when carbon dioxide gases pass through lime water, so lime water turns milky. That means the color of the lime water, so this is lime water. Okay, so this is lime water, and its color will turn into like this. Okay, so that means little bit white type of color will start to appear. So this is said the lime water turns milky when carbon dioxide gases pass through the lime water. Okay, so what is the chemical reaction? This is the chemical reaction, that is calcium hydroxide. It is the formula of lime water. Okay, so lime water means calcium hydroxide, and when we add carbon dioxide to it, the solution will turn milky. Okay, why it is turning milky? because calcium carbonate is formed. Okay, so due to the reaction between calcium hydroxide and carbon dioxide, we will get a new product, that is calcium carbonate and water. Okay, and this change is also a chemical change because a new product is forming. Again, it is the change is permanent and change is irreversible. Okay, so now we are looking at the last example, that is, this is also given in your book. So what we are taking, in this beaker we have copper sulfate solution. Okay, and copper sulfate solution is blue in color. So we have copper sulfate solution. What we have? Copper sulfate solution. Okay, so here we have copper sulfate solution which is blue in color. Okay, so then what we'll do, we'll take a nail. Okay, nail means in Assamese it is called kozal. Okay, so we are taking a nail which is made up of iron. Okay, and we'll put the nail in the solution and we'll keep the solution for 2 to 3 days. Okay, for few hours or few days we'll keep the solution like this. So after some time, what we will see, that the color of the solution changes to green. Yes, so earlier the color was blue. Yes, then we put a nail in the solution and then color change into green. Okay, so that means what we can see, there is a change in color. Okay, so that means a change is occurring. Okay. So why the change is occurring, we will see now. Now what happens, this is the formula of copper sulfate. Okay, this is copper sulfate. Yes, so the solution of copper sulfate is blue in color. Okay, so that means this solution is of copper sulfate. Okay, CuSO4. Okay, so the blue solution is of CuSO4. Okay, and what we have done, we have put a nail in this solution. Okay, and we will see that the color changes to green. Yes, so why it is, because a chemical reaction is occurring. Yes, so what is the chemical reaction? That is, this copper sulfate is reacting with the iron. This copper sulfate is reacting with the iron which is present in the nail. Yes, and it is giving us a different substance which is ferrous sulfate or iron sulfate. Okay, so the formula is FeSO4. Okay, so this formula is of iron sulfate. Okay, and this iron sulfate gives a green colored solution. Okay, and we will get copper which will be deposited in the iron nail as a brown color substance. Okay, so if you look here, so in this part you will see that the color of the iron nail has changed into brown color substance. This is because the copper which was present in this blue color solution, now it gets deposited on the surface of the nail. Okay, and a new substance, that is ferrous sulfate, FeSO4, that is ferrous sulfate or iron sulfate. It is formed and it is green in color. Okay, so in this reaction also what we see, that this change is, in this sense also we are getting new substance, that is FeSO4 iron sulfate, which is a new substance which is formed. Again what we see, that the color is changed. Yes, earlier the color of the solution which was copper sulfate was blue, and now when the change occur, we got a green color solution, and which is due to iron sulfate. Okay, and we can also see that the change which is taking place is permanent and irreversible. Yes, okay, so from all these examples we can see that all the examples here we saw that a new substance is formed, that the change is permanent and irreversible. Again, in some example we saw that somewhere we are seeing change in color, somewhere we are seeing that heat and light is evolved, somewhere we are seeing that gases is evolved. Yes, so that means from this conclusion of the different example that we saw, we can write the properties of chemical changes. Okay, so here I am giving you the properties of chemical change. Okay, So what are the properties of chemical change? That in every chemical change we can see that a new substance is formed. Okay, then in every example that we saw that the change is permanent and irreversible. Okay, and since in every substance, in every example we saw that a new substance is formed, so that means what? The composition is changed. Okay, so only when composition will change we will get a new substance. Okay, so suppose in the example that we saw in our earlier classes, that is melting of ice. So in that example we saw that the composition remains same, that is composition of ice and water, both is H2O. Okay, but in the last example that we saw, that is of copper sulfate and iron sulfate, we saw that the earlier blue color solution, the composition was CuSO4. Yes, but when we got the green color solution, we got a new product, that is iron sulfate, and its composition is FeSO4. Yes, so that means the composition has changed from this to this. Yes, so in a chemical change we will also see that the state or composition is changed. Okay, again we see that the heat or light may be given out or may be absorbed. Yes, so in cases of burning of the matchstick, what we saw, in cases of burning of the ribbon, what we saw, that both heat is given out and we also get light. Okay, when we burn the magnesium ribbon or when we burn the matchstick. Yes, so in some cases we will also see that a new smell is being produced. Okay, we will get a new type of smell when the change occur. Okay, so earlier we will not have any change in smell, that is the smell of the substance which was originally present will change when a chemical change will occur. Okay, again we saw that color will also change. We will see that color also changes. Yes, so the color of the copper sulfate solution was blue and it changed into green when iron sulfate formed, that is during a chemical change the color also changes. Okay, and in our earlier example, that is when washing soda was mixed with dilute sulfuric acid, we saw that carbon dioxide it is formed. That means carbon dioxide is a gas, that is a gas is formed. Okay, so during chemical changes sometimes we also see that gases are formed. So these 7 properties of chemical change we can write from the examples that we have seen. Yes, so these are the properties of chemical changes that we have to know, and on the basis of these properties of chemical change you can tell the difference between a chemical and a physical change. Yes, so we will have different properties for different type of changes. That is, for physical change we have different properties that we saw in our last class, and for chemical change the properties are different that we are seeing now. Yes, so some other examples of chemical change. Okay, so this is not physical change, this is chemical change. Okay, so some other examples of chemical change are rusting of iron. Okay, so we will be looking at this example in more details in our next class. Okay, so we will be needing one more class to finish this chapter. Okay, so rusting of iron we will be seeing in details. So cooking of food is an example of chemical change. Why chemical change? Because once the food is cooked, okay, you cannot get back the raw food item. Suppose a vegetable is cooked, okay, so you cannot get back the uncooked vegetable once it is cooked. Okay, suppose a potato is fried. Yes, so from the fried potato you cannot get back the original raw potato. Yes, so once it's fried means it's fried, you cannot get back the original raw potato. Okay, so digestion of food. So what is digestion of food? It is a chemical change. Why chemical change? Suppose the food which you have eaten once. Okay, suppose you have eaten an apple. Okay, so once the apple is eaten by you, you cannot again get back the original apple. Yes, so you cannot put your hand inside your mouth and you can bring out the original apple from your stomach. You cannot do that. So that means once the food is eaten, so it is completely changed. Okay, you cannot, it is permanently changed. It is not reversible. It is an irreversible change because you cannot get back the original food. Again, rotting of vegetable and fruits. Yes, so once a vegetable gets rotten, we have to throw it. Okay, so you cannot get back the fresh vegetable once a vegetable gets rotten. Again, photosynthesis. So what is photosynthesis? It is the process by which plants make their food in presence of sunlight and chlorophyll from water, carbon dioxide, and some nutrients which are present in the soil. Yes, so mainly from carbon dioxide and water, plants make their own food in presence of sunlight and chlorophyll, and this process is known as photosynthesis. So once they make food from carbon dioxide and water, they cannot again reverse it. Okay, so they cannot again make carbon dioxide and water from the food they make. Yes, so therefore photosynthesis is also an example of chemical change. So now difference between physical and chemical change. So it is nothing but the difference between the properties of physical and chemical change. So that we all know, that is physical change is temporary, chemical change is permanent. In physical change, no new substances are formed. In chemical change, new substances are formed. Physical change is reversible, chemical change is irreversible. So composition changes during chemical change, but composition does not changes in physical change. Okay. In physical sense, energy is not absorbed. In chemical sense, energy in the form of heat or light may be given out or it may be absorbed. Yes. So I think this is all for today's class. In the next class, we will be looking more in the importance of chemical changes and on some important chemical changes like rusting of iron, okay, crystallization process. So we'll be looking at this and we'll finish this chapter on the in my next class. Okay, again one more thing that I am asking you to subscribe my channel so that you can get some important question answer whenever I discuss them. Okay, so if you want, you can subscribe the channel to get some additional question and answer whenever I will be posting it in my channel so that you can get them easily. Okay, so if you want, you can subscribe the channel. Okay, so thank you.